Okay, these are the first 5 questions from section 8.2 on solving two-step equations with fractional coefficients and constants, as well as decimal coefficients and constants. And our first question says 2x plus a half equals 5/4. Now, it could have also said 2x plus a half equals 1 1/4. These are the exact same question, but we're going to write down what it said. It says 2x plus a half equals 5/4. It just made it easier by taking the mixed fraction and making it into improper already. So there are 2 ways we could solve this. The first method that we could use is to simply subtract the constant from both sides, right? Working towards isolating the variable. So this would be 2x equals, and once we have it written like this, we need to find our common denominators. And we need to subtract the numerators to get 3/4. Now our next step, if I was to isolate, I want to get rid of the coefficient of 2. And since coefficients are multipliers, we're going to divide both sides by 2. Here I'm going to divide it by 2 to get x. But over here, I'm going to write it as division by 2. Or more specifically, if you want to write it so you can see it better when we use the reciprocal, 2 is also written as 2/1. We then take our first fraction, change to multiplication, and use the reciprocal to give us a final answer of x equals 3/8. Now, alternatively, we could have employed the second method of solving this equation by multiplying both sides by a common number, or by a number. In this case, if I was to multiply this side by 4, algebraically speaking, if I was to multiply this side by 4, I would maintain balance of the equation. And that idea is the principle behind all of the algebraic equations we do. And if you understand that principle, then we know that we have 3 terms. We have one term here, 2x. We have one term here, a half. And we have one term here, which is 5/4. If we think about what the denominator is in all of those terms, the denominator of 2x is really 1. Even though it's not written, we know that whole numbers have denominators of 1, including algebraic terms. They would have denominators of 1. And if I was to write the multiples of 1, 2, and 4, I would realize that 4 is the first multiple they share. It also shares 8. It also shares 12. It shares a whole lot of them, but those are ones they share. So because of that, if I was to multiply this side by 4, and remember, this is the idea here, so it's times 4 times 4. I'm not multiplying one term. I'm multiplying the entire side. So because there's 2 terms here, I need to place it in brackets, and I need to think about that idea of distributive property, because both terms are going to be multiplied by 4. And if I multiply one side, I have to multiply the other. And I'm just going to press pause for a second on this idea and go over to a different idea. If I take any fraction, and I'm just going to take 2/3. And if I think of the denominator of 3, and I write out all the multiples of 3, etc. If I was to multiply 2/3 by any of these multiples, 3, 6, 9, or 12, and I'm just going to choose 3 first. If I was to multiply it by 3, I would get 6/3, which is equal to a whole number of 2. If I was to take that 2/3 and multiply it by a second multiple of 3, like 6, I would get 12/3, because of course 6 is 6/1, which of course is a whole number of 4. And that works for every whole number I would multiply 2/3 by. If I multiply a fraction by a multiple of its denominator, it will always equal a whole number. It will no longer be a fraction, it'll be a whole number. So because that is true, if I choose a multiple of all 3 of those terms that the denominators share, in this case 4, all of those terms will cease to be fractions and will start to be whole numbers. So what I'm going to do is I'm going to take that 4, and in fact I might just write it as 4/1, multiplied by 2x/1. Then I'm going to write that 4/1 multiplied by the positive 1/2. And then I'm going to write that 5/4 multiplied by that 4/1 as well. So all 3 terms are being multiplied by 4/1. This is going to give me 8x. So when I multiply this, it's just 8x/1, or just 8x. Here, I'm going to cross reduce, and I'm going to get a positive 2 I'm going to write that as a positive 2. And here, I'm going to end up with a 5. So when I multiply both sides by 4, I get this equation. And now I just have to use my grade 7 sense to get rid of the constant by subtracting 2. 8x equals 3. Divide both sides by 8. And x equals 3/8. Or, if you wanted to do it, you can do 0.375, which is what 3/8 is as a decimal, or 3 divided by 8. Your next question is very similar. And for these ones, I'm going to alternate how to solve it. I'm going to do this one by getting rid of the constant, and I'll do the next one by getting rid of the coefficient. So here we're going to add 2/5 to both sides, creating a 0 pair. I get 4x equals, because I'm adding 2/5, that's pretty simple, because 3/5 plus 2/5 is 1, or 5/5 actually, it's 5/5, which is 1. Then divide both sides by 4, and x will equal 1/4, or 0.25. My next question gives me a constant first, then a negative 2.5x, then equals 3/10. Now for this one, I'm going to solve it using the common multiple way. Now there's a little bit of pre-steps getting your equation ready to make it easy to do. So I'm going to keep my first one here as 4/5. Actually, I'm not going to write that yet. What I want to do is remind me tomorrow. What I want to do is I want to think about ways I could rewrite this term. So this second term is negative 2.5x. And there are multiple ways we can write that. If I was writing it as a decimal, it'd be negative 2.5x. That's one way to do it. If I was writing it as an improper fraction, it would be negative 5/2x. But if it was an improper fraction of negative 5/2x, and a coefficient of negative 5/2 is being multiplied by x, because that's what coefficients do, then another way I could write this would be negative 5x/2. Okay? So if I think about that, let's use my highlighter here. That's the coefficient, and it can be written either this way or this way. Both ways are still representing negative 2.5. And if that's the coefficient, then there it is there, and it's being multiplied by x. And when we multiply the numerators, we get this, and we multiply the denominators, we get this. So I did that whole string of thought to simply tell you that before you do your question, if you know that, then it's going to be easier to rewrite the equation as this. 4/5 minus 5x/2 equals 3/10. That 5x is just bothering me, because 2.5x is really 5x/2. So now that you have that, we're going to look at our multiples of 5, 2, and 10. And if you were to think about it, 5, 10, 15, 10, 20, 30, 2, 4, ... 10. 10 would be the first multiple they share. And because that's the first multiple 5, 2, and 10 share, we're going to multiply both sides by 10. Use your brackets to remind yourself that it's more than one term that has to be multiplied by 10. And multiply this side by 10 as well. And again, just to remind you, not to be redundant, but if you multiply one side by 10, another side by 10, it will maintain equality. Because you have more than one term, you need to use distributive property. And when you get to this point, keep your whole number over 1, for those of you who struggle with multiplication a little bit. So 10 is going to be multiplied by 4/5. 10 is going to be multiplied by, now this here negative sign, just slap it in with your numerator here just to remind yourself it's going to be a negative term. Negative 5x/2. And then it's going to be 3/10 multiplied by 10/1. Okay? So now, cross reduction. Because you're multiplying, you are able to cross reduce. 10/5 will reduce down to 2/1, leaving me with 8/1, or just 8. 10/2 will reduce down to 5/1. Now be careful here. Because when you multiply the numerators, 5 multiplied by negative 5x is going to be negative 25x over 1, or just negative 25x. And your last one, when you cross reduce, you're going to get equals 3. Now we have a constant of 8, so I'm going to subtract 8 from both sides. Negative 25x is equal to negative 5. Dividez-vous both sides by negative 25. And x will equal 1/5, or 0.2. And remind yourself it is positive, because a negative divided by a negative is a positive. Question 4, we'll solve the regular way. So x over 2 plus 1 2/3 equals 1/6. So probably if I was doing this question, the first thing I would do if it was me, oh, that's not a 3, that's a 2, is I would rewrite 1 2/3 to be 5/3. Okay. And then if I'm doing it the regular way, I'm going to get rid of my constant by subtracting 5/3 from both sides. Leave me with half of x is equal to, now here's tricky, remember, 1/6 take away 10/6 is 1 take away 10 over 6, which is negative 9/6. Some people have a difficult time with that 1/6 take away 10/6, and they end up with 9/6, not negative 9/6. Now we have this, so what we're going to do is we're going to multiply both sides by 2. Getting rid of that and isolating the variable. Cross reduction, it's a beautiful thing. 1 over 3, negative 3 over 1. So your final answer is x equals negative 3. Now if you didn't cross reduce, you would have ended up with negative 18 over 6, which will still equal 3 when you work it out. Negative 3. And question 5, the last one for this video. Consider your decimal coefficients. So x over 0.6 plus 2.5 equals negative 1. I think most people would agree these equations with decimal coefficients and constants are very easy because there is no difference between grade 7 and 8 math. It's simply, you might have to use a calculator. Get rid of the constant by subtracting 2.5 from both sides. Negative 1 take away negative 2.5, or combine the two would be negative 3.5. Multiply both sides by 0.6. And you would have 21. X equals negative 21. If you take your calculator just to make sure, because sometimes if a brain doesn't work. Negative 3.5, if you're terrible with integers, use your negative sign. Multiplied by 6/10. Oh, sorry. Equals negative 2.1. I was a little off. Negative 2.1. Now, if you're having difficulty with this, the next video, they should say the next 5 questions, they will again deal with similar things. So if you're using this to study, you of course could watch the video and press pause, try the question and press unpause to make sure you're doing it correctly.